In this video, we will see some problems on continuous exponential Fourier series. So first, let us find the continuous exponential Fourier series for the impulse train. Here, the impulse train means it is nothing but a periodic train of impulses. It is nothing but periodic train of impulses. Okay, so let us first draw the representation of impulse train, graphical representation of impulse train. This is my t and this is my x of t. In this case, it is nothing but delta t naught of t. Right, this is my origin. Let me draw the impulse trains in a different color. So my first impulse is at 0, right? How do I draw an impulse? A straight line with a arrow, right? That is my first impulse, and my next, and its amplitude is 1, right? Because amplitude is nothing but the strength of the impulse under the curve, right? So it is 1. This is of height infinity and width 0. So when you multiply, it comes to 1, right? Width very small, not 0 exactly, but very small. By definition of impulse, the amplitude is 1 here, and it is at the position 0. And here, if you look at this, it is an impulse train. T naught here represents the period of the function, period of the impulse train. That means every t naught seconds, or every t naught seconds here, every t naught seconds, the impulse repeats, right? The impulse repeats every t naught seconds. That means again at 2 t naught, there is another impulse. Again here at negative t naught, there is a impulse, and then again at negative 2 t naught, there is a impulse, right? All of this have the same amplitude. So if you look at it, it is a periodic impulse train, periodic repetition of impulses. That is nothing but our impulse train. So for this signal, we have to find the continuous exponential Fourier series. So first, let us look at the formula for continuous exponential Fourier series. What is the formula for continuous exponential Fourier series? F of t is equals to summation n is equals to minus infinite to plus infinite, fn. Fn is your Fourier coefficient, e power j n omega naught t. This is my formula. So first we have to find fn. So let us calculate the value of fn. What is the formula for fn? Fn is nothing but 1 by t integral over one time period, right? Integral over one time period. I can consider 0 to t, or let me say 0 to t naught here, or from here also, right? Minus t naught by 2 to plus t naught by 2. I can consider this also as my interval. So here what is t? T is equal to t naught. So I'll write t naught here, and my upper and lower limits for the integration, I'll consider minus t naught by 2 to plus t naught by 2, minus t naught by 2 to plus t naught by 2, then f of t, right? F of t. What is my f of t here? It is nothing but x of t, that is delta t naught of t, delta t naught of t e power minus j n omega naught t dt, right? Then delta t naught of t in these limits of minus t naught by 2 to plus t naught by 2. What is it? We just have an in this limits we only have this impulse, nothing else, everything else is 0. So this is equal to delta t naught of t in this interval is equal to just what is this? A single impulse, that is delta of t. So I can write it as 1 by t naught, 1 by t naught integral minus t naught by 2 to plus t naught by 2 delta of t e power minus j n omega naught t dt, right? Now look at this, here. We have this sampling property of impulse, right? Integration minus infinite to infinite, delta of t into x of t dt is nothing but x of 0, right? This is the identity. So I'll apply the same identity here, right? I'll apply the same identity here. My function here is x of t is just a single impulse, right? Single impulse. So I can write as 1 by t naught, 1 by t naught. X of t here is e power minus jn omega naught t, e power minus jn omega naught t at t is equals to 0, right? So if I substitute t is equals to 0 here, it is nothing but 1 by t naught, 1 by t naught. This whole thing becomes e power 0, that is 1, right? This part goes to 1, right? So this is my fn. So what can I do now? I have my fn. So all I need to do is substitute the value of fn in this form, right? So what is the function we have? We have a periodic impulse train, that is delta t naught. T naught is nothing but the period of the signal. T naught of t is equals to summation n is equals to minus infinite to plus infinite. Fn, what is my fn here? Fn is 1 by t naught. So 1 by t naught, 1 by t naught, and e power j n omega naught t. So this is my Fourier continuous exponential Fourier series of my periodic impulse train, right? So I can draw the amplitude and phase characteristics for this signal, right? Here my fn is 1 by t naught. Fn is 1 by t naught. So what is my mod fn? Mod fn, magnitude of fn magnitude of Fn is also 1 by T naught, right? And my phase of Fn, what is my phase angle? This is a real number, right? 1 by T naught is a real value. There is no imaginary value here, so the phase is 0. Phase is 0. Phase I can represent it as angle of Fn or theta of n. Any way I can represent my phase. So let us draw the representation here. Representation, let us draw. So consider this is my mod of Fn, and this is my n value, right? This is my n value. So what I can do here, this is my origin. What is my value of f at Fn at n is equal to 0? N is equal to 0. For any n, the amplitude is always 1 by T naught. So 1 by T naught, right? The amplitude is 1 by T naught. At n is equal to 1, at n is equal to 2, n is equal to 3, and so on. Similarly, at n is equal to -1, at n is equal to -2, at n is equal to -3, and so on. So for any value of n, the amplitude is 1 by T naught. 1 by T naught. So n value is only an integer. It cannot be any number between the two integers, right? N value is an integer. So this is my amplitude characteristics. Similarly, I can draw phase. Phase. Against n, right? Theta n, or angle of Fn. Phase is always 0. So for any value of n, the phase is 0. So 0, 1, 2, 3, and so on. -1, -2, -3, and so on. So here also it is 0. So this is my phase characteristics, and this is my amplitude characteristics. So we can call this amplitude spectrum, right? Amplitude spectrum, and this is my phase spectrum. Amplitude versus n, or n omega naught. Here I can write n omega naught also. So when I write omega naught here, this will be 0, omega naught, 2 omega naught, 3 omega naught, right? Amplitude or phase against the frequency, or n or n omega naught, is called spectrum, right? It is called spectrum. So this is my complex exponential Fourier series of impulse train. So let us do another problem for a periodic gate function, right? Periodic gate function. Gate is nothing but a rectangular function, right? That we have already seen in elementary signals. So this is my gate function here, right? So I need to find the complex exponential Fourier series. So first I have to find Fn. What is Fn? It is 1 by T, 0 to T, right? 0 to T, f of x of t here, x of t e power minus j n omega naught t dt. That is equal to 1 by t. I will consider my lower and upper limits to be from this point, till this point, right? This is my time period. I can consider from 0 to t, or I can consider from this point till this point, because this is the one that is repeating. So I can write minus tau by 2 to tau by 2. In this range, what is my amplitude? It is a e power minus jn omega naught t, right? E power minus j n omega naught t dt. Then a is a constant divided by t. Integration of e power minus j n omega naught t is e power minus j n omega naught t divided by minus j n omega naught, and the limits are minus tau by 2 to plus tau by 2. Now let me substitute the limits. A by t, a by t, and I have minus j n omega naught. Everything is independent of t, right? This is all constant, so I can get it outside as a constant. So minus 1 by j n. What is omega naught? Omega naught is again 2 pi by t, right? And let me substitute the upper and lower limits in my e power minus j in omega naught t. So first term will be e power minus j n omega naught tau by 2 omega naught tau by 2 minus e power minus j n omega naught. In place of t, now we have negative tau by 2, so this becomes positive, right? Positive tau by 2. Then let us continue here. We have a by t and t cancel. What do we have here? We have j n 2 pi, and this is in the form of, that is in the form of e power minus j theta minus e power j theta, right? E power minus j theta and e power minus j theta. I'll multiply this minus sign here inside, right? So let me rewrite this here. When I multiply, I'll get e power j n omega naught tau by 2 minus e power minus j n omega naught tau by 2, right? This 2j here this 2j here, I'll take it inside. Right now, then what will happen? Then it will be equal to a by n pi, a by n pi. If I get it inside, what is this? E power j theta minus e power minus j theta divided by 2j. That is nothing but sine. That is nothing but sine theta, right? Sine. What is theta here? N omega naught tau by 2. N omega naught tau by 2. So here I'll substitute the value of omega naught. What is omega naught? Omega naught is nothing but 2 pi by t. It is 2 pi by t. So a divided by n pi into sine 2 pi by t. If we substitute, 2 gets cancelled. I am left with n pi tau by t. N pi tau by t. Now what I'll do? I'll multiply and divide by tau by t. Let me multiply and divide by tau by t. Tau by t. Now this numerator and this numerator, I'll write it separately. A tau by t, a tau by t into sine n pi tau divided by t divided by, in the denominator we have n pi, and here also in the denominator we have tau by t. So that is nothing but a tau by t, sine x by x. What is sine x by x? It is nothing but sampling of x, n pi tau by t, n pi tau by t. So this is my fn. So all I have to do is let me take a different color. My x of t is equals to summation n is equals to minus infinite to plus infinite. My fn value I'll substitute, that is a tau by t sampling of n pi tau by t, right? This is my sampling of n pi tau by t, n pi tau by t e power j n omega naught t, or j n omega naught t. So this is my exponential Fourier series for gate function, periodic gate function. Now let us see one more problem for continuous exponential Fourier series. So this is my x of t. What is x of t? If I find out the line equation for this, x of t is nothing but at in the range of where is t defined. T is defined in the only this range, right? Now t is defined only in this range. But we know Fourier series can only be found for periodic signals. So we can assume this is my period. So my signal will be something like this, right? My periodic signal continues to be something like this, right? So this is my x of t, and my capital T is equals to 1, right? 0 to 1. So again, I will find my Fn. Fn is equals to 1 by t. What is 1 by t? T is equals to 1, and then 0 to t. T is again 1. My x of t in this range is a small t into e power minus j n omega naught t dt, right? So if I integrate this, this is in the form of u dv, right? T is my u and this is my dv. So if I integrate it, what is the formula I have? Integral u dv is equals to uv minus integral v du. So what is u? U is t. V is going to be integral of minus e power minus j, sorry, integral of e power minus jn omega naught t. So integral is going to be e power minus jn omega naught t divided by minus jn omega naught, and the limits for this will be 0 and 1, minus integral v du. V is e power minus jn omega naught t divided by minus jn omega naught 0 to 1 du. U is equal to t, so du is equal to dt, right? That is equal to a. So if I substitute 1 here, so what do I have? E power minus jn omega naught divided, okay, jn omega naught divided by minus jn omega naught. If I substitute 0, it becomes 0. Then minus integral of e power minus jn omega naught t is nothing but again e power minus jn omega naught t divided by minus jn omega naught. We already have minus jn omega naught in the denominator, so square, and my limits are 0 to 1. Then a into e power minus j n omega naught divided by minus j n omega naught minus, here if I substitute, so there is t here, if I substitute 1 in place of t, I have e power minus jn omega naught divided by minus j n square omega naught, sorry, minus j n omega naught whole square minus in place of t if I put 0, I have 1 by minus jn omega naught whole square, right? Jn omega naught whole square. Now that is equal to a into, let me take an LCM, right? What is LCM? I'll take minus jn omega naught whole square. This is my LCM. So what will this become? It is equal to minus j n omega naught into e power minus j n omega naught minus e power minus j n omega naught plus 1 plus 1. Now what is e power? Okay, here in place of omega naught I can substitute, in place of omega naught, what is omega naught? It is nothing but 2 pi by t, but we know t is 1, that is omega naught is equals to 2 pi, right? In place of omega naught here, if I substitute 2 pi, what will this be? E power minus j n 2 pi, right? This portion, right? This portion, and this part, and this part, e power minus j n 2 pi. So what is e power minus j n 2 pi? It is nothing but, what is it? Cos 2 pi, cos 2 pi minus j sine 2 pi, right? Cos n 2 pi is always 1 minus j sine n 2 pi is always 0. So it is nothing but, this is going to be replaced by 1. So if I continue, a into minus j n omega naught, this is 1 minus, this is also 1, so 1 plus 1 divided by minus j n omega naught whole square. Now minus 1 and plus 1 gets cancelled, and we're left with minus j n omega naught divided by minus j n omega naught whole square. So this also I can cancel. So my final answer is going to be a divided by minus j n omega naught. If I take minus j to the numerator, it becomes j a by n omega naught. In place of omega naught, I'll again substitute 2 pi. So j a by n 2 pi is my Fn, right? This is my Fn, but this does not exist when n is equals to 0. When n is equal to 0, the value is infinity, right? So again I will find f naught separately. What is my f naught is nothing but 1 by t. In place of t we have 1, 0 to t, 0 to t, at, right, a t dt. So there I have a into t square by 2 from 0 to 1. That is nothing but a by 2. A by 2. So this is my f naught and this is my fn, right? So if I write the final equation, it will be something like this. X of t is equals to, what is f naught? A by 2 plus summation n is equals to minus infinite to plus infinite. Minus infinite to plus infinite means it will include 0, but we have already written the value at n is equal to 0. So we will exclude n equal to 0 here. Right? We will just exclude n equal to 0 here. Fn is j a by 2n pi e power minus j n omega naught t. Sorry, e power plus j n omega naught t. This is my final exponential Fourier series for the given signal. So this is how we find the Fourier series, both trigonometrical complex Fourier series. So next we have properties of Fourier series. Properties of Fourier series. This is the first property. When f of t has Fourier series f of n and g of t has Fourier series f gn, then for this function, which is a linear combination of f of t and g of t, that is a into f of t plus b into g of t, the Fourier series will be defined as fzn, which is nothing but a into Fourier series of f of t plus b into Fourier series of g of t, right? That is the first property. It's called linearity property. The next one is time shifting. If f of t has the Fourier series fn, then the time shifted version of f of t, that is ft minus t naught, will have the Fourier series ffn into e power minus jn omega naught t naught, right? The magnitude is going to be the same. Only thing, we are introducing a phase coefficient here. So a time shift in the time signal, a shift in the time signal results in phase shift of the Fourier coefficients. Here there is a time shift, here there is a phase shift, right? Time shift by t naught, phase shift by t naught, e power minus jn omega naught t naught. Similarly, frequency shifting. So what happens if there is a frequency shift in the Fourier series here, right? If there is a frequency shift, then there is a corresponding phase shift in time series, time signal. So if f of t has a Fourier series fn, then e power j n naught omega naught t into f of t has the Fourier series f of fn minus n naught. Then the next one is time scaling. F of t has Fourier series ffn, then f of alpha t also has Fourier series ffn. Time scaling, if you scale the original input signal, the Fourier series, there will not be any difference. It is the same. And these are other properties. Time differentiation or integration. If you differentiate the signal in time, this is how your Fourier coefficients change. This is the multiplicative factor for the original coefficients, right? Similarly, if you integrate from minus infinite to the present point t, so how will your Fourier coefficients change? This is the multiplicative factor 1 by jn omega naught. Then convolution. There are two time functions f of t and g of t with Fourier series ffn fgn. Then if you convolve f of t and g of t, then the Fourier series of this convolved function is going to be ffn into fgn into t naught. It is nothing but product of the two Fourier series and multiplied by a factor of t naught. T naught is nothing but a period, time period. Similarly, multiplication. That multiplication in time domain results in convolution in Fourier domain. Here, convolution in time domain results in multiplication in Fourier domain. One domain it is convolution, the other domain it is multiplication. That is nothing but these two properties. Convolution in time domain, multiplication in time domain. Convolution in time domain is nothing but multiplication in frequency domain or the Fourier domain. Multiplication in time domain is nothing but convolution in Fourier domain. Next one is symmetry. If f of t has Fourier series ffn, then f star of t, f conjugate of t, has the Fourier series f conjugate of minus fn. So all these properties can be proved. We look at the proofs of Fourier transform properties in the second unit. The proofs of these properties also, all the properties of Fourier series, will be similar to those in the Fourier transform. So you can practice those later after we finish the second unit. So this is the end of first unit.